welcome to Sunday's edition of Cracking the Cryptic, and have we got a puzzle for you guys today? This puzzle is an interesting one indeed. It's by Jesper Josefsson, who's appeared on the channel I think twice before, once in our ASMR video special, in which I whispered throughout the video. Some of you enjoyed that. Many of you didn't. I won't be whispering today, don't worry. But the reason I think that we're in for a very special edition today is that I've had several requests to solve this puzzle from people. And I've had 2 recommendations about it as well, and it's not been out very long. It's appeared on Logic Masters Germany. It has an enormously high approval rating. And I think that the requests I've been getting are due to our Sudoku Puzzle Hunt, which that came out a couple of weekends ago. Was it last weekend? I've lost track of the days. And it featured a puzzle called Helga's Cup, which was based on, I mean, I'm not giving away any secrets by revealing that the theme for our Sudoku Puzzle Hunt are the Harry Potter books, and in particular the Harry Potter Horcruxes, or Voldemort's Horcruxes. And the Helga's Cup puzzle featured a rule set that is very similar to this puzzle, and I know that in terms of the difficulty of the puzzles from the hunt, Helga's Cup is one of the real head scratchers. So I'm wondering whether the reason that people are cottoning onto this puzzle and asking me to look at it is because it might help people with the Helga's Cup puzzle from the Sudoku Puzzle Hunt. Well, I hope that's true, but whether or not it does, this puzzle on its own should be an absolute belter. The way you play the puzzles on Cracking the Cryptic is very simple. You click on the link under the video and that takes you to a page that looks identical to this one, and you can play on whichever device takes your fancy. And with that, I'm going to have a go. Oh no, actually I need to tell you the rules first. What am I talking about? I'm going mad. What are the rules? Actually, let me just get them in my on the screen here. We've got normal Sudoku rules. We've got the Helga Hufflepuff rule, this German whispers rule, which means adjacent digits along the marked grey lines have to have a difference of at least 5. And then we've got sandwich clues outside the grid. How do they work? Well, these are normal sandwich Sudoku clues, so they're telling you the sum of the digits between the 1 and the 9 in the row or column. So let's look at the 20 clue just to look at an example. Let's imagine this was a 9. Let's imagine that square was a 1. Then the 20 is telling you the sum of the cells sandwiched between the 1 and the 9. So these 4 squares would have to sum up to 20. And that's the way sandwich clues work. And now I really am going to get cracking because I've told you the rules. We're all on the same page. So let's get cracking. And probably this is where I'd start, I guess. 35 is the maximum sandwich clue because we know that every row or column or box in a Sudoku will contain all of the digits from 1 to 9. If you add up those digits, you get the number 45. So, sandwich between the 1 and the 9, what is the maximum you could possibly have? Well, it's 45 minus 1 minus 9. It's 35. So we actually know that the 1 and the 9 have to sit right at the edge of column 5. And I'm tempted. Shall I do shading? I'll try and hold off on shading. Sometimes with sandwich Sudoku, it's a very good idea to shade in cells that can't be 1s and 9s. So you could shade in these squares, for example, but I'm not sure whether it'll be necessary to crack this one. Actually, I am going to do it. I am going to do it because I want to... This 9 clue down here, that must be at least 2 cells. Therefore, these 2 squares can't be 1s and 9s. So maybe I should keep track of that. 27 as a sandwich clue is quite interesting as well because you can't have a 1 or a 9 in the central box. If we try and put a 1 there, the furthest away I could put the 9 would be this square, which would only allow me to create a 4-cell sandwich. Well, if the maximum you can make a 4-cell sandwich is 8, 7, 6 and 5, which add up to 26. Not enough. So these, what that tells us is that we can extend our green lines. These also have to be green. Okay, and I think I've run out of gas now with these sandwich clues. So probably we have to look at the German whispers clues now. So we've got to think about the parity of these lines, because these lines are very interesting in terms of Sudoku setting, actually, because they alternate value. I think this form of Sudoku has an awful lot to give. So we know, for example, if we could lock in that this was a 1, then the parity of the line would be to always have a low digit in those 4 positions and a high digit in those 3 positions. So we have to try and get a handle on this to try and crack the puzzle. Right, and there's a few tips for either the Helga's Cup puzzle or this one, I guess. First tip, which is really obvious as soon as you think about it, is that a line can never contain the number 5. Because if we put a 5 on the line, how do we put a digit that's 5 away from 5 on either side of it? Well, there are no digits. There are no valid digits. We can't put, a 0 in the Sudoku. So 5 is a no-no in terms of the lines, but 4s are also really awkward. 4s and 6s can never go in the middle of a line. Well, actually that's not strictly true, but they certainly can never go in the middle of a line like this, because the implication would be you'd have to put a 1 on this side and a 1 on that side, which obviously doesn't work. The time when you might be able to do a 6 is, for example, in a cell like that. That could be a 6 because you can hide the 1s away from each other like that. So that would be where 6 might be possible, but definitely, yeah, this central box is really quite, in fact, particularly these 3 squares are interesting, because they're always got to deal with those 2 squares as well. So these 3 squares simply cannot be 4, 5 or 6 or 1 or 9. So they've got to be 2, 3, 7 or 8. Now this is very suspicious, isn't it, in terms of the 27 clue. So sorry, let me explain why I think this is suspicious. It's because of the cells outside the sandwich in this row. So if we think about, we know we're going to have a 1 and a 9 in the row, and between the 1 and the 9 we're going to have cells summing to 27. So 1 plus 9 plus 27 is 37. So there are cells summing to 8 that are outside the sandwich total. Now how do we make that 8 total up? There's 2 possibilities. It's either going to be an 8 sitting on its own in one of these squares. That's possible. Or it's going to be 2 cells summing to 8, and that we don't know where those 2 cells would be. But look at these options now in here. Yeah, so in fact, because these need to oscillate, if we have a situation where these are both low digits, that breaks the puzzle. Because if these are both low, what do I put in here? It has to be a digit that is 5 away from the higher of those 2 squares. It has to be 8. This is a beautiful idea. It's a beautiful idea. This is impossible. This is impossible because it breaks the sandwich clue. We can't now put an 8 on its own on either side because there's an 8 in the middle box. And we can't put 2 cells that sum up to 8 outside the sandwich because 2, 6 and 3, 5 are not available. And 1, 7 isn't available because 1, 9 has to form the sandwich. So this is not going to work. Which means that we have to put high digits on the edge, which means that one is a low digit. Now that means yeah, this is beautiful. This is just so cool. So now the 8 is definitely in one of these 2 squares. Therefore, we're looking at a 2-cell sandwich. And because we need to we know there's a 7 in one of those 2 squares. That square there can't be a 3 because that's not going to be 5 away from the 7. That has to be a 2. Therefore, we know that the cells outside the sandwich here are not 2 and 6. They are going to have to be 3 and 5. And you can't put 5 on a line, so the 5 has got to be in one of those two squares. Now, is there a way of telling which of those is... Well, if that... Ah, got it. This can't be the 5. This can't be the 5. Because if this is the 5, this square must be the 3, because obviously if this is outside the sandwich, this must also be outside the sandwich. So the 1s and the 9s get placed into those positions. And what do we have to put into those positions? 4 and 6. Now that, you can't put a 4 and 6 in the middle of a line like this, because we've already looked at it. What would we put either side? We'd either have to have 2 9s or 2 1s, and that is not allowed in Sudoku. So let's undo this. We can actually say with certainty that this is not the 5, this is a 5. And I can get rid of the colour and make it green. Now the 3 clue is important. So we now know that the 3, which is outside the sandwich cell, is either here or here. But it can't be here, because if it's there, it has to be surrounded by a 1 and a 9 because of the sandwich clue. And now, wherever the 1 is, it's not 5 away from the 3. So this is nonsense. This doesn't work. The 3 must be there, which means those two squares have got to be 5 away from 3. They've got to be an 8-9 pair. And we've got the 5 and the 3 now in row 5, which means we can place the 1 and the 9. Which means those two squares are 4 and 6. What a puzzle this is. What an entry. It's just, you know, it's just got such a lot of cunning to it. So now these two squares are high, so these two squares have to be low, but they can't be a 2, and they can't be a 4, because neither of these can be a 9. So these two squares are a 1-3 pair. And of course, because this is a 1 or a 9, yeah, look, the 3's here. Where does the 3 go in column 2 of the grid? Why is that? Why have I got a big warning sign on my computer down there from Windows? That's a bit worrying. Ooh. Can I won't pause the video. I'll just wait for it to crash. So the 3 in this column, look, it can't go here. It's going to have to go there, which means the 1 or the 9 must go here. I am a bit worried about what this is going to say. Let me just look at it. Close programs to prevent information loss. Low on memory. Google Chrome. Bother. Hang on a moment. Let me just try and do this. I'll go... how do I do this? Problem is I'm so useless at computers that I don't know how to do... I've just tried to close something. Maybe that's worked. Maybe, oh, the warning's gone away. The warning's gone away. We are good. Okay, God knows what I've just lost by closing all those windows down. But we won't worry about that. We will get on with solving this puzzle. So I can actually make all of these squares green now. Now is that important with this? Yes, it is. Look at this 1-9 clue now. So we've got a 9 clue in row 9 of the grid. Now if this if this comes leftwards, so this is the sandwich filling, they would have to be 2, 3 and 4. Well, you can see that doesn't work because 2, 3 and 4 are not oscillating. They are too close to each other. So we actually now know that we know that this is turning right. This square's got to be green. Oh, we do the same trick again, presumably. So if we try and put the 1 and the 9 in the corner, these 3 squares become 2, 3, and 4, and that might look like it works, but it doesn't, because these squares now have got to be 5, 6, 7, and 8. And again, we're going to have the same problem. These are on the line. They need to be 5 apart, and they're clearly not. So this doesn't work either. So this 9 clue is not a 3-cell sandwich, which means this is a 1 or a 9. Which means this is not 2, 3, and 4. This is green. And oh, yes, look at this. This is important. We can use the 3 to disambiguate the 1 9s. I could have done this before, but I was disturbed by my computer breaking on me. The 3, obviously this is on the line, so this can't be a 1, that's got to be a 9. That fixes that, that fixes that, that fixes this, that fixes that, that fixes that. Now, surely that is important, is it? So this square now has got to be low and can't be a 1 or a 3, so that's got to be a 2 or a 4. And look, we now know the parity of this line because we've managed to lock a low digit onto it. So we now know this is a low digit, so it's got to be a 3 or a 4 because it can't be a 2. This is a high digit, but it's got to be far enough away from a 3 or a 4 to be 5 away, so that's an 8 or a 9. This is a high digit, can't be a 9, that's a 6, 7 or an 8. It can't be a 6, because if it's a 6, that square would have to be a 1, and we'd repeat the 1 in the row. This is classic German whispers trickery. So this square's now got to be a 2 or a 3. Can't be a 4 because this can't be a 9. This square has got to be a 7 or an 8. Again, it can't be a 9. And this square has also got to be a 2 or a 3 because it can't be a 1. And it can't be a 4 because this can't be a 9. Good grief. So we get a 2-3 pair here. Let's make sure everything is turned green that needs to be. Oh, of course. And look, one of these squares is a 3. So this square needs to be at least 5 away from the largest of those 2 digits. So it can't be 7. That's 8. That's 9 now. Oh, where does 9 go in the middle now? It's got to go there. This 9 fixes the 9 and the 8 on this side. That locks an 8 into one of those 2 squares. Oh, 9's here by Sudoku. Force a 9 into this square. So 9's up there in one of those 2 squares. Same on this side, one of those 2 squares. That's a bit suspicious. Oh, this is gorgeous again, isn't it? This is going to impact on the 20 sum. Let me just tidy up. This is where I want to look next. Once I've tidied up down here, I just want to check on whether I can do some more Sudoku. 1's down here. 3's 1. Oh, 1's over there in one of those 2 squares. These 2 digits are both low, so these 2 digits are both high. So they can be 6, 7, 8 or 9. These 2 digits have got to be low. They've got to be 1, 2, 3 or 4. Okay, so it's got to be a 3 in one of those cells by Sudoku. Let's now have a look at this 20 clue, because look, these 9's form a sort of X-wing pattern. So let's ask ourselves, where does the 9 live in row 3 of the grid? Now, if this is a 9, we know for certain this square is a 9. If, on the other hand, this is a 9, then it's just a 9. So we know one of those 2 squares is a 9. So we always end up with a 9 look in one of these 2 cells. Now why does that matter? Well, it matters because of the 20 clue. 20 must be at least a 3-cell sum. So whichever one of these happens to be the 9, you can never put a 9 in those 3 squares. So they all have to be green. You can never put a 1 in one of those 3 squares. I'm not sure if I said 9 in one of those 3 squares, but you can never have a 1 in one of those 3 squares. So the 1 now, look, let's ask where the 1 goes in this row. Yeah, because look, actually I can make all of those green because I've got the 1-9 pair here. But basically the 1 is going to have to live in one of those 2 positions in row 3 of the grid. So that is also interesting. Because I don't know which way round this clue works now, this 20 clue, but I know that if this is the 9, the 1 would have to be there and we'd have a 5-cell sandwich. If this is the 9, on the other hand, the 1 has to be here and I'd have a 5-cell sandwich. So however this 20 clue works, there is always a 1 and a 9 outside a 5-cell sandwich, which means I've used 7 of the cells in the row. So the other 2 cells have to add up to 45 minus 10 minus 20 is 15. They have to be 7 and 8. So there's either a 7-8 here or there's a 7-8 here. So these 2 squares can't contain a 7 or an 8. Actually, look, there's a 7-8 here or a 7-8 here, so this square can't be a 7 or an 8. This square and this square can't be a 7 and an 8 because of the 7-8 pair in box 5. This can't be a 7 or an 8, so there is a 7-8 pair now in column 5. So this... that feels like it might matter. Oh, well, there's an 8 here, so that gives me a 7. That gives me an 8. That gives me the 8-7 in the middle. It gives me an 8 here. This can't be 7 because we know that there's a 7-8 pair on one side of row 3. So the 7 must go there. Good grief. Now, yeah, this is perfect now. Look. I can disambiguate these 2 squares. The 7 needs to be 5 away from a digit, so it can't be a 3 there. That's a 1, that's a 3. And now the 6-9 get disambiguated because the 3 can't be next to the 6 on the line. And now the 9, it's backfired into this 20 clue. Now the 20 clue, I know the configuration. The 1 has to be as far away as it can be. Obviously can't put the 1 here. I can't make that square add up to 20 on its own. These 2 squares now have to be the 7 and the 8 outside the sandwich total. So the 8 here gives us an 8 and a 7. So 7 in one of those 3 squares. This is not 9, so we now know this is the 9 in this box. 8's got to be there by Sudoku. Look, that's these 8's interacting. And look at the line here. This line, it needs to have a high number on it, and it can't have a 9, 8 or a 7, so this has to have 1 and 6, and there's a 1 there. So this is a 1, this is a 6. This is a 6. There's a 6 in one of those 2 squares, 6 in one of these 2 squares. Wow. 6 here, look, fixes that that's a 4, so that's a 6. 6 lives in one of these squares down this side. 4 fixes that this is a 2. 2 lives in one of those 2 squares. This square yeah, looking at this row, look, we need 2, 3, 4 and 5. There's a 2, 3 here, so this is a 4 or a 5. That can't be a 1. That can't be a 3. 2, 3, 4 and 5. Ah, there we go, look. So if we look at row 3 of the grid, these 3 squares here, because this can't be a 2 or a 3, the 2 and the 3 in row 3 have to be in 2 of these 3 squares. So there can't be a 2 or a 3 in that square as well. That becomes a 4. That becomes a 1 because it can't be a 2 or a 4. And we might be getting closer to a solution. So I've now used the 20 clue, I've used the 3 clue, I've used the 35 clue. I've used the 27 clue, I've not used the 9 clue yet. 7's got to be in one of those squares though. Oh, and 6 as well. 6 has got to be in one of those squares. That's beautiful because that looks a 6 here, gives me a 7. That's a 4 by Sudoku. This is a 5 by Sudoku. And now the 9 clue gets resolved because I've got a 6, 7 and 8 in the row. These have to be 4 and... well, that's a 6 for starters. And this is a 4, 5 pair. This is a 2 or... ah, this is a 2 or a 3. In fact, I'm going to be able to place the 6 here as well. That's a 6, that's a 1. This is a 2 or a 3 and it can't be a 3, so that's a 2, that's a 3, that's a 2. This isn't 6 anymore, so these 2 squares have got to be a 4, 5 pair. There's a 4 here, it's all coming together now. 5, 4, 5, 4, 3. This is not 3. These 2 squares are 2 and 5, which we can do. And these 2 squares are 3 and 7, which we can obviously do as well. That plonks a 7 into one of those squares. 3's into one of these squares. In fact, what do we need up there? 2, 3 and 4, look. So 4 must be in one of those, 2 in one of those. These squares up here have got to be 4, 5 and 7. Ah, so maybe... well, that square's got to be a 7 then, because this one can't be. And that 7 is on the line, so this square now has to be low, and it can't be a 1. So this has to be a 2 or a 3. In fact, there's a 2, 3 pair into those 2 squares, look. I feel like that should be resolvable, but I can't quite see how to do it. These 2 squares have got to be 6 and 8. The 8 there tells us the order. So that's 8, that's 6, that's 1. This is 7. This is 7, this is 2. This is a 4, 5 pair, which is now resolved. These 2 squares are also 4 and 5, which are resolved. That places the 4. Oh, this is nice, isn't it? Look at this. Oh, I see. Yeah, of course. The 7 is too close to a 3, and that's going to disambiguate this deadly pattern at the top of the grid, because this is forcing this one not to be a 3, that's a 2, and that fixes everything, look. It's just absolutely stunning, it really is. That's an 8 by Sudoku, and you can see that hopefully, if I haven't made a mistake, these 3 squares have got to be 2, 3 and 5, and we should just be able to place them like that. And that is how to solve Jesper's absolutely brilliant puzzle. That was so original. The logic in that, combining the sort of Helga's cup logic with sandwich logic, it works superbly. Loved it, absolutely loved it. I hope you guys enjoyed it too. And we'll be back later on with another edition of Cracking the Cryptic. Now please, when I stop this video, do not crash. Do not